Good afternoon, guys. Implicit differentiation. This is our lesson for today. So, if we are given this function, y equals 4x squared plus 2x minus 3, this is defined explicitly. Okay? So, if you have this kind of equation, it's hard to solve for this in terms of y. And so we can solve for this or define this implicitly. Okay, so that is why in our previous videos, in our previous discussion, we were able to directly get the derivatives of our functions, all right, which were defined explicitly. Now, how do we obtain or determine or solve for the derivative of functions such as this? Okay, so we have here the first example. For example, we have x squared plus y squared equals 7xy. So this problem is taken from the book again of the Calculus with Analytic Geometry by Lighthold. This is one of the exercises found in his book. Okay, and by the way, what we are going to do right now is now what we call implicit differentiation. Okay, so the derivative of x squared is 2x and the derivative of y squared is 2y. And since we are differentiating y in terms of x, so we add dy dx. So the derivative of y squared is 2y. And since it's variable y and we are differentiating it in terms of x, so we add dy dx. Equals 7 of u times v. So x times the derivative of y is 1. And since it's y, then we have dy dx times 1 plus y. Then since we are differentiating x, so we simply write 1 without the dx dy. Alright, so I hope we are very clear with that we add dy dx if we are differentiating y, because that's differentiating it in terms of y, in terms of x. So we bring down 2x, then 2y dy dx, all right? And then we multiply this, so you have 7x dy dx, and multiply this, so you have 7y, okay? Then dy dx, those expressions containing dy dx should be placed on the left side of the equation, on the left side of the equal sign. Okay, so we have 2y dy dx, all right, and then transpose this to the right side so that you have negative 7x dy dx. Then bring down 7y and transpose 2x to the right side so that you have negative 2x. Now, this is common, right? So we have dy dx of 2y minus 7x equals, bring this down. Then, transpose this to the right side so that dy dx is left there on the left side alone. So, 7y minus 2x divided by 2y minus 7x is your derivative. Okay? So, we're done. And this is called, again, implicit differentiation. Another example in terms of trigonometric functions, you have x sine y plus y cos x equals 1. Again, this problem is taken from one of the exercises of the Calculus with Analytic Geometry of Lighthold. Alright, so this is u times v. This is also u times v, so you expect u dv plus v du. So x is your u, the derivative of sine y is cos y, derivative of y is 1, and since we are differentiating y in terms of x, we have dy dx. Plus sine y, then derivative of x is 1, okay? Plus y, derivative of cos x is negative sine x, derivative of x is 1, plus cos x, derivative of y is 1. And since we are differentiating y in terms of x, so you have dy dx. And the derivative of 1 is 0. So, we simplify. So, x times cos y is x cos y dy dx plus sine y. Then, negative y sine x, and then we have cos x dy dx. So we combine x cos y dy dx and cos x dy dx and transpose those without the dy dx on the right side of the equation, so that this comes first because it's negative. Once you transpose to the right side, it will be changed to positive. So it's better that what comes first is having the positive sign, because again, it is not very good. It is not good that you face your day or you start your day with a negative vibe. So always start with a positive vibe. Then sine y is transposed to the right side, so that becomes negative sine y. Then of course, this becomes the common dy dx, and you have x cos y and cos x, which will be transferred or alright, so transposed to the right side of the equation. So you have y sine x minus sine y divided by x cos y plus cos x, which is your final answer. Okay, and lastly, we have the third example. Again, this example was taken from the material Tisiwag by Lighthold. So the derivative of cosine is negative sine, and copy x plus y. And then the derivative of x is 1. Then the derivative of y is also 1, but since that's y, then we add dy dx. Then this is in the form of u times v. So y, then the derivative of sine x is cos x, derivative of x is 1 by the chain rule. Although that's x, no, some students would not add 1, but I would like to emphasize this because there are times that we are careless and sometimes we forget. We tend to forget to differentiate, okay, the terms here. Alright, so we have sine x and derivative of y is 1, and since it's y, we have dy dx. Okay, so let's simplify. We have sine x plus y times 1 is negative sine x plus y. Sorry, we have the negative here. The negative sine of x plus y times this one, so you have with dy dx. Okay, then this is y cos x, and this is also sine x dy dx. So we have this on the left side, the dy dx, as well as this one. So we transpose it to the left side, so that sine x dy dx becomes negative sine x dy dx. And that we bring this down and transpose this to the right side, so that that becomes positive because this one is negative. So positive sine of x plus y. Then dy dx here, notice that I also bring along the negative sign so that we have here all positive. Okay, so sine x plus y and then plus sine x, and then bring this down and this one. Also bring that down here, copy, divided by this one. Okay, this is now transposed here. But of course, bringing along with it the negative sign. So whether the negative sign is located in the denominator, no, in the numerator, as long as you enclose the terms, no, properly, because that's negative, still, no, if you go back to your equivalent fractions, they are the same fractions. Okay, so this is your final answer. So that's the end. Okay, that's the last example for implicit differentiation. Thank you very much. This is Dr. Batukan saying, mathematics is easy to learn when one learns with enthusiasm. Always smile. Bye.